On today's Maker's Mashup, spring is here and we're going to be building a soil sensor so you can monitor your plants and gardens from Home Assistant. Welcome makers, spring is here and now is the time to start building your soil sensors for your garden and for your home houseplants. So like many of you in the spring and in the summer, we like to plant a lot of plants and have a little bit of a home garden. A lot of our plants are generally container plants. So one of the things that I wanted to build this year was a much better working soil sensor. Last year I tried to build one and I ran into all sorts of troubles, especially trying to use solar powered devices to keep these powered. Long story short, I found it much easier to simply run some USB cables to the particular places that I needed with regular 5-volt power. I don't really work in an area where these are very remote. They're very close to power outlets in my home, and when I use them indoors, most of the plants aren't too far away from a power source. So I decided to simplify this project and really make it something where you just require regular 5-volt power. I also ran into some things on AliExpress that I might want to try at a later date. These are solar panels with batteries already in them, and they provide a much more consistent power level. If you know of a couple of good ways to power this project, let me know down in the comments. I would love to hear your suggestions for it, because my work with solar panels was very, very disappointing. So let's talk about the sensor we're going to be building today. So these are the type of sensors we're going to be building. They're very, very small and compact. They are capacitive soil sensors. Now these work by reading the capacitive values and returning back to a WeMOS D1 the voltage sensor settings, or basically the voltages based on the capacitance being read by the sensor. So it's a really easy project to put together. I've got a great little 3D print that's also included with it, and the 3D print allows you to get up and running quickly and easily with this project. Overall, you should be able to build one of these sensors start to finish in about 3 hours, including the time to print the 3D prints. So with all that said, let's get to work. All right, so we're going to put our sensor together, and we've got a number of parts here. We've got our WeMOS D1 Mini. This uses an ESP8266, and this has Wi-Fi enabled on it. Now this one uses a USB-C connection. A lot of these also use the USB mini connection. So when you buy your power adapter, make sure that you're buying a WeMOS that matches, or a power adapter that matches the WeMOS. This cable here comes with this capacitive soil sensor. This says version 1.2. I've used this for a while now. Some people claim it's not a 1.2, but regardless of its version, the sensor seems to work fine and has been doing a pretty good job with my plants so far. Along with the sensor and the WeMOS, we've got a couple of screws and some 3D printed parts. That's really all there is to assemble this. You will need to get yourself some solder and a soldering iron to do just 3 points of soldering here. Really straightforward and easy project. So let's jump right into it. So the first thing we're going to do here, this cord is entirely too long, or this jumper wire is too long. The enclosure is very small here, so we really only need about this much of the cable here. Now I've already got one here that I've cut up. I don't like to cut these until I'm actually ready to use them. And we're going to strip just a little bit off of here, and then we'll tin these wires before we put them in here to make it a little bit easier. These are my favorite wire cutters here. These are some Knipex. The reason I like these so much is the adjustment at the top here. You can adjust how much pressure these jaws clamp down on your wire. Now you can make your own wire stripper with a 3D printer. Doesn't really matter as long as it gets the job done. I always like to hold these, and then there we go, we've got our stripped wire. So to tin these, what I've found always works the best is just a little bit of rosin, and what I do is I just take my rosin and just barely touch the wires to it. And then with soldering iron, I'm just going to touch a little bit of solder here. We'll just put this right on the desktop here. Touch a little bit of solder. Let me clean that tip off. Touch a little bit of solder, and then just gently touch the end of the wire leads. And that rosin, what rosin does is it cleans the metal, and then it also makes it so that way the solder attaches much easier. So those were all really easy to tin. And then once you've got them tinned, this is a good example here. You might be able to see it, but there's a little bit of fraying here. I just like to trim off the ends on these, and then I've got really nice clean wires ready to go into our WeMOS. Now, the way this is designed to work, this is a little carriage for this enclosure, and the way that this works is this will just drop into place here. So we're going to need to wire our wires on this side with the little metal cover there on your WeMOS. So wiring this up here, we're going to use our sticky tack, and we're going to start with our 5-volt lead. And wiring this is really easy. You've got a 5-volt and a ground pin. So we'll do both of these at the same time. So we'll take our black and red, make sure you have your polarity right. And then we're going to put the 5-volt and the ground in, and then just going to use our sticky tack to hold everything in place. Once we have these two in here, you just want to clip that extra lead off there. And that's good. So then for this is going to go to the A0 pin. A little bit hard to read here, but the one down from the reset is the A0. And we'll just put this one in as well. And here we go, we'll just solder this one. That's it. We've got our whole sensor wired up. Really, really straightforward. So after you get this wired up, we're gonna put this in this little carriage. And the little V is pointing up, so it looks like a letter V. And then this just pressure fits. And you can see here, there's a little slot. Now, the reason this is a little bit wide is some of these shift over a little bit left and right, so I try to leave a little bit of clearance there for poor manufacturing. And we can just plug this in here, and that's it. This sensor will work, we just have to program it. So to assemble this piece here lines up with the screw holes. So the screws are going to come down from the top. So you just have to align that with the screws, and then you're just going to drop this carriage into place. We're going to hook up the USB cable. We'll just plug this in here, and this piece here gives a little bit of clearance for the cord. So the only real thing you need to note when putting the lid on, there's a very, very small lip here, and there's a very, very small groove here on this side. Once the screws go in, you won't be able to open it up. So you only need screws on one half of this print. And then you just drop the screws in. We're gonna grab our wow stick here. Make sure that your sensor is not where the screws need to be. And then we'll just drive these in a little at a time to get started. All right, so as you can see, once you drop the screws in here, we got a pretty solid connection. Everything cord-wise only comes out from this one side, so if you want to put silicone on the inside, you can. That will help seal it. I suggest making sure you program it and it works okay before sealing it up. It only takes a second to put those, take those screws out and replace them. And then you can see here the top lid stays on because of that little groove that I've got in there. So we've got a fully assembled sensor. So now that we have the hardware set up, we're going to need to get the firmware installed on here and hook it to Home Assistant. So you can see I'm in Home Assistant here, and I've gone to ESPHome. If you don't have that installed, you'll need to go to Settings, and then you'll need to go to Add-ons, and then install the ESPHome in the add-on store. Once ESPHome is installed and you're all ready to go, we're going to set up a new device. The easiest way to do this, I've found, is with the ESPHome web app. So when you click this, it's going to take you to an external website, and it will allow you to connect to your device. So you just click connect, and then you can see this device is here. If your device is not showing up, you most likely need to get the ESP8266 drivers for the different chips. There are serial chips, and there are a couple of variations out there. I'll have some links in the description that will get you to getting those drivers set up if you don't have them already installed. So once we've got our connection, the next step here is to prepare the device for first use. So you just click this, and then you click install. And if everything goes okay, it should take about a minute to get everything installed. Now, if you're not a subscriber of a channel, while we're waiting for this installed, that would be a great time to click that subscribe button and hit the bell so you don't miss any of the upcoming videos. And it really does help the channel. I really appreciate it a lot. All right, so if your configuration is all installed correctly, you should get this message. You can then click close. It will then connect back to the same device, so you can set up Wi-Fi, and you'll need to do this and connect it to your individual Wi-Fi network and enter its password. Once you've done that, it should provision your device and connect it to the network. We'll confirm this by clicking Visit Device. All right, you can see I've connected here, and it's given my IP address with .102. If you ever need to know which the device address is, when you click that Visit Device, it will take you to the web page. And this saves you a little bit of time if you have trouble setting it up inside Home Assistant. So now that we've got our sensor online, you can see here that there's no sensors or anything going on with this device. This is what we're going to have to go to the wiki page for. So inside the wiki page, I've got some ESPHome code, a couple of things that we'll have to do. Just make sure that we're using the higher CPU speed, and then we're going to also cut and paste some of this code before we do our calibration. So inside ESPHome, if we go back there, you should see now that your device is on the network, and it allows you to adopt it. Once you click adopt, this is the place that we want to rename our device. Now for this one, I'm just going to be calling this one an office sensor, and then hit adopt. Once it's done, then it needs to install the encryption key. Now you can skip this process, but for the sake of this video, it's much easier to click install and update the code. All right, so it compiled successfully, and you can see it's now uploading over the air and resetting our device. So at this point, you can just click the stop button here, and then we need to go back into our sensor. So we'll click edit, and you can see here we've got all of our different sensor codes. So the first thing we need to do is update the header portion. So we're going to go back to our wiki page, and we'll just copy these options here. So here we're gonna just click the copy button from our HydroGuardian wiki page, and then we're just gonna go to the end. We're gonna paste in the sensor, and this configures a couple of things. I'll cover it quickly. It does configure a blue light, so you can turn on a light if the sensor detects a little moisture. This is good for a visual cue, so while you're checking out your plants, you'd be able to see that that one might need some water without having to go to Home Assistant. The other thing we do here is configure the analog to digital sensor, and the capacitive soil sensors do use the analog port and give us different voltages, which we have a linear calibration for, and then the plant moisture level. So with everything good here, we just need to paste those in, and then we're going to save it, and then we're going to install it. And once again, we'll wait for this to recompile and update our sensor. All right, so once again, it's doing an OTA update here. And once the over-the-air update is complete, it will reconnect back to the sensor. So at this point, the sensor should be working within Home Assistant. So we're going to go back to our web page here that had our sensor, and we'll refresh this page, and we should get it to come back up here in just a second. Sometimes it takes the sensor just a moment to reboot. All right, so our sensor has now rebooted, and we're starting to see some data coming in here. All right, so you can see our sensor is pulling in new data now, and this sensor updates approximately every 30 seconds. So the only piece that we have to do at this point, you can see here that I'm reading 10% moisture. The sensor is obviously not in any soil moisture, so this is where we have to configure it. And the process for configuring is really pretty straightforward. The sensor voltage, this sensor here shows us how much voltage we're getting from the capacitive soil sensor. And then this is back in our code here. So if we edit this, you can see down here, this is our linear percentage. So if we go back here, what I like to do is give the sensor a couple of times to stabilize, and then you're going to copy whatever the lowest value you see is from the voltage data. So we're going to copy this, and then we're going to go over to ESPHome here, and then we're going to update this 0 with our new value. And then we're going to go back to the sensor, and this is the part where you need to do the calibration. We're going to take our sensor and we're going to put it into this little beaker of water. And then that's going to change in about 30 seconds our sensor value. And then we're going to copy that 100% or fully saturated value into Home Assistant again, and then we're going to recompile it. So I like to give this again another couple of minutes just to make sure that the value stabilizes. All right, so we've had a couple of sensor updates here, and we're going to copy this value, and then we're going to assign this to 100% saturation. And then we're going to save, and once again, install. All right, so our OTA update is complete. And once again, this is going to reboot our sensor. We can just click stop here, and we're going to go back to our plant sensor. And once again, we'll refresh this. We'll take a couple of refreshes for this to come back up. But once it does, then we can see where our moisture level is at. It should read roughly 100%. And we've got a little bit over, about 101%. You can always go back in and update this value again. So if you decide that, oh, I've seen a value here that is much lower than the other one, then you can just paste in that new value, and your sensor is always going to be a little bit more accurate. When you really think of plant moisture overall, you're not looking for single percentage digits. So the accuracy here is not ultra important unless you have a particular plant species where you're trying to keep a range of moisture with some accuracy. So at this point, we're almost done. We just need to now adopt the sensor inside Home Assistant, and this should be really straightforward. If you go to the notification section, you should now have a new notification for your sensor. And you can see here we have our office plant sensor. All we have to do is click configure and then submit, and the sensor is now part of our Home Assistant. So I'm going to assign this one to the office, and then I'm going to click finish here, and that's it. We're done. We have a sensor that is inside Home Assistant that is reading our plant's moisture. Now all we need to do is set up any automations that we want to do with this sensor. All right, so here we have our new automation, and we're gonna add a trigger, and we're gonna do this based on a time pattern. And we'll set this for basically every minute. I'm gonna set this for 0 seconds. And then what will happen is every minute at the top of the minute, we will trigger this time pattern. And the condition is gonna be based on our device. So we're gonna put in here plant, and grab our office plant sensor, and then moisture level. And so if we want to trigger it above or below a specific value, this is in the percentage that we're receiving back from the sensor. So in this particular case, if we get below 30% voltage, we want to trigger these actions, and the action is going to be on the device. And then we will set this up so our devices are plant again. And then we're going to turn on the blue light. And that's it. So once we save this, and we'll call this the office plant. And then save it. So each time that it is triggered, it should then turn on the blue light if it's below 30%. And we should be able to test this easy enough by simply running the automation. So if we run the automation, we can see here, a little bit hard to tell, but maybe if you look in those holes, the blue light is on here. It's a lot easier to see in person, but the blue light is on because this is just sitting dry, and because it's just out in the dry, it's below 30%. So that's how you can trigger that. You can obviously use the inverse and trigger it as to turn off the light once the moisture level comes up above 30%. So as you can see, putting one of these sensors together is really pretty simple. Soldering and getting it assembled really less than 30 minutes. 15 minutes if you've soldered projects before. And the 3D print on my machine with Clipper only takes a couple of hours for all 3 pieces. So it's a really quick project you can do on the weekend, and getting it installed in Home Assistant is easy with all of the instructions on the wiki page. Now, I built these for monitoring my plants, and I would be really interested to know if you're going to use this for plants or gardens, and some of the suggestions that you have for a version 2 of this sensor. I also want to take a moment just to thank all my patrons for all of your support. Thank you so much for everything that you do. It really does help the channel, and I want to thank all of the viewers as well for all of your viewership and for purchasing products from some of the links down below. It's really helped the channel over the years, and we're really producing more and more videos here every single week. So with that, I want to say thanks again for watching, and we'll see you all next time.